Optimizing radiographic technique refers to taking those settings and making them the best possible settings, optimizing them, yeah? So our recommendation is for mass and KVP, MAS, milliamperage seconds, MAS, and KVP, kilovoltage peak, we would like to have, if all else being equal, high KVP settings and low MAS settings, low mass settings. These are generally recommended with digital equipment. Different than a flashlight. So whereas a flashlight, right, changing the voltage on the flashlight changes the color of the light, in the X-ray beam, we can't see the X-ray beam, right? So we're not actually changing the color of the X-ray beam when we change voltage, when we change KVP. What we're doing is we're increasing or decreasing the penetrating capability of the X-ray beam. More or less of it will penetrate the body depending on voltages, depending on KVP, okay? So this is the relationship. High KVP is highly penetrating. Low KVP is less penetrating. Wouldn't it be better for more of the X-ray beam to pass through the patient, right? High KVP is better because more of the beam passes through the patient. High KVP, highly penetrating. When we have to increase radiographic technique, like let's say you go from a small patient to a large patient and you have to go up in technique to go for the large patient, it's better to do the increases with KVP changes, okay? If you go from, let's say, a large patient down to a small, or let's say go from the average patient down to a small patient, you'd have to decrease your radiographic technique. It's better to do the decreases by decreasing the amount of X-rays, not the energy of the X-rays. So decreases in technique should be made with mass. Increases in technique should be made with KVP. That's how you're thinking of it. That's how you should start to think about these things.
Can you repeat that last part?
Yeah, so increases in technique should be made with KVP. Make the beam more penetrating. Decreases in technique should be made by changing mass, decreasing mass. Okay, let me give you an example.
Yeah.
So we have the average patient here. The average patient, let's say they're 10 centimeters thick, and our technical settings. Okay. Let's go to, actually, let's do this. Caliper in here? I do not. I gotta grab some. Right back.
What do you think about that fight with Nate and Jake?
Well, they're gonna fight UFC too, but yeah, man, I think Nate's getting, he takes a lot of punches, you know what I mean?
Yeah, he's
But,
tough.
Jake Paul's been training 4 years straight.
Yeah.
I mean, real boxers will
Yeah.
train 2-3 times, a year.
Yeah.
But I think if he has the right training, for a YouTuber, he can still pull in the pay-per-view buys.
What if you're
I
calling
need someone who's
Canelo
not shy about getting their thickness measured. You want to volunteer?
Hey,
All right, Sergio.
why?
All right.
I was doing chest the other day. So.
Okay. So, Enrique volunteers to get his thicknesses measured. We're just gonna measure. We're just gonna measure we'll measure AP thickness just for his lumbar spine area. Okay. So this is, by the way, this is a caliper. This is used to measure body thicknesses. It measures in inches or centimeters. We'll use a centimeter measurement. Okay. Now, when you use a caliper, you want to also, I'm going to pull this off for just a second again, make sure your patient's standing, not laying down. When we lay down, we tend to kind of flatten out a little bit. Also make sure that you're not pushing this caliper into them, squeezing them. You just want to bring it to where the soft tissue is. Okay, so all right, let's go ahead and do this. Right about the belly button-ish level. I'll bring the caliper in, take it out, and we have him right at 26 centimeters A to P. Okay, so we're going to call him our average patient. All right. So, where'd my marker go? There it is. So we're going to call him the 26 centimeter average patient, okay? We'll put the large patient over here. this small patient over here. All right. Now, let's make this easy on ourselves. Let's make the large patient only 4 centimeters thicker. Let's also make the small patient only 4 centimeters thinner. So these are the thicknesses for the small, average, and large patient in this like lumbar spine area. Okay. Now let's just imagine that the technical factors 80 kV and 30 mass were the correct settings on our machine for this for Enrique. Okay. Over to the large patient. This large patient is 4 centimeters thicker. Okay. So what do we know we're going to have to do? Ignoring like exactly the changes that we make, what are we going to have to do? Increase technique, right? Because this large patient is thicker, right? How much do we have to increase technique by? We'll get there, but just as a general idea, we have to double our technique, okay? Twice as much, right? We have to double the amount of technique we're using, technical settings, because every 4 centimeter, so let me write this rule down, 4 centimeter rule. Okay, so the rule is called the 4 centimeter rule. And it states that you should double your technique for every 4 centimeter increase in patient thickness. That little rule right there, we'll let it sit there. It also goes the other way too. For every 4 centimeter decrease, halve your technique, cut it in half. Okay, so there's one way to double technique. Let's talk about the large patient. One way to double technique would be to double the amount of x-rays produced. Which one of these two settings controls the amount of x-rays produced? Mass, right? Okay. So I've put myself in a little bit of a corner here, but let's see if I can make room for this. So one option, we'll put option 1, would be to stay at 80 kVp and double the mass for this large patient. So what's double 30? 60.
What are we doing? Chest?
Oh, we'll call it lumbar spine. Okay. This is one way. Okay. Now, how much more exposure is the large patient going to get than the average patient? Double. Right? The average patient gets half as much as the large patient using option 1, okay? So this is one way to double technique. Option 2. So we just said increases should be made with kVp, not mass. This increase we made only with the mass, right? So this is one option we can do, okay? Option 2. Leave the mass alone, so carry over the 30 mass, and make your changes by changing kVp. Okay, so let's come over and read this. This doesn't say it that well, but let me try to say it in the ways that we can understand. A 15% increase in kVp will do the same thing at the image receptor as doubling the mass. So if instead of doubling the mass, you just went up 15% in the beam energy, the kVp, you will do the same thing as doubling the mass. Okay, so option 2 is to take 80 kVp, raise it by 15%. I don't have my phone on me, so someone's going to have to do this for me. I know roughly what it should be, but yeah, okay. So, and just real quick to do that, put it anywhere on here, we go 80 times 1.15. Or you can go 80 times 0.15 and then add it back to itself, but that's just an extra step you don't need to do. Okay. So Abby told us 92 kVp. Okay. Here's the cool thing. Option 1 and option 2, the images will look identical. You will not be able to tell the difference between the two images. Okay. However, Option 1 doubled the patient's exposure from small, average to large patient, right? Option 2 does not double the patient's exposure because the amount of x-rays produced remains the same. All we did was increase their energy. This does increase exposure though, okay? So option 1, we'll say like 2 times the exposure, right? This one here, so let me rephrase this. We'll say 100% increase in exposure, okay? 100% more, right? Option 2 is only about a 40% increase. Sorry, 40% increase. So which one's better for the patient? Option 2. If they both look identical on the image receptor, but one of the options is way better for patient's exposure, you should choose the one that's better for the patient's exposure. So, said in another way, increases in technique should be made with KVP changes. It's better for the patient. Let's go to this side of things. Same thing, 4 centimeter rule. This time we're going down in technique. Okay. So option 1 would be to cut the mass in half. Okay. So we would carry over the KVP, leave it alone, and cut the mass down to 15. How much less exposure is the small patient now getting compared to the large? Compared to the average patient. Excuse me. Half. So said another way, it's a 50% decrease. Yeah. Okay. Option 2. What would you do for option 2? Instead of changing mass, you change KVP. And how much would you decrease it by? Sergio? 15%, right? Okay. So somebody work that out for us here. It'll actually be 80 times 0.85 because you're trying to go down 15%. 80 times 0.85.
68.
There you go. All right. This option 2 carries over the same mass. So does the amount of x-rays change? No. What has changed to option 2? KV. So the energy of the x-ray beam, not how much of it there is, right? This is a decrease in exposure, but not by changing, what do we got?
It says it is disconnected, and then it has a red X through the Wi-Fi symbol.
Oh, we could have lost Wi-Fi. I'm going to come help you guys in just a second, okay?
We didn't want to mess with anything.
No, that's okay. I'll come check on it. All right, so option 2 is a decrease in exposure by changing KVP, okay? So exactly like going up in KVP was a 40% increase, going down in KVP will be a 40% decrease. I'm getting kind of sloppy here with my writing, but a 40% decrease, okay? So what's better for the small patient? A decrease of 50% or a decrease in exposure of only 40%?
40%.
Right, would you rather have 50% less exposure or only 40% less exposure? You'd rather have 50% less exposure, right? So when you're going from average and going down in technique, what's it better to do? Change mass or change KV? Mass. When you're going up in technique, what's it better to do?
KVP.
Change KVP. This is why, okay? Because the patient benefits best with decreases by going down in KV. Going down in KV. Mass, sorry. Patient benefits best by going down in mass. When we go up, patient benefits best by going up with KVP. So up with KVP, down with MAS. Okay. That gives you an explanation of why. Let me pause.